So when we're talking about numbers, we can take any value, any number, and you can write it in what we call prime form, primitive, most basic form. A prime number is a number that is basically made up of only two factors, 1 and itself. So for example, the number 2 is prime because 1 times 2 is the only thing that gives you 2. Number 4 is not prime because 4 is made up of 1 times 4 and 2 times 2. So a prime number are the numbers that are the most basic, that are only divisible by 1 and itself. The reason that's important for you guys to know what the prime numbers are is because you could take any composite number, and a composite number is made up of more than just 1 in itself. You could take any composite number and you could break it up into prime factors. So, for example, if I look at the number 28, 28 is not prime because it's made up of 1 times 28, it's made up by 2 times 14, and even 4 times 7. So it has 3 math facts that multiply to give you 28. You can break it down to prime factors by using any one of those 3 math facts and then taking each number and breaking it down even more. So in the example, they used 4 times 7. 4 is not prime. What numbers does 4 break down to? 2 times 2. But 7 is really just 1 times 7. So when you look at this that you see up here, this is called a factor tree. This is called prime factorization. What you have done is you've taken 28 and you've broken it down to 4 times 7. 4 was broken down to 2 times 2, and 7 is just 1 times 7. Each of these is prime. 1 is just understood to be there, but the prime factors of 28 would simply be 2 times 2 times 7. And you notice that those 2 2's that we see here are written in what we call exponential form. 2 to the power of 2 times 7. This is the prime factorization of 28. Review. All of 7-1 is just a review of prime factors. So you guys try. 32. What is the prime factorization of 32? So give me a math fact that gives you 32. 8 times 4 or 2 times 16. It doesn't matter, right? Which one you begin with. If we break it down to 8 times 4, is 8 prime? No. How do I break 8 down? 2 times 4. Is 2 prime? Yes. Is 4 prime? No. So I break 4 down to 2 times 2. And these are prime. What about the last 4? That guy has to break down to 2 times 2, which now you notice that I have 8, which is broken down to 2 times 2 times 2, right? 8 is 2 times 2 times 2, and 4 is 2 times 2. How would I write this in exponential form? Two to the power of 1, 2, 3, 4, 5. Exactly. That is the exponential form of 32, once we have written it down in prime factors. The downloaded form. Okay, what about 31? Is 31 prime or composite? Prime, because nothing except 1 times 31 gives you 31. So the prime factorization of 31 is just 31. How about number 3? Number 3, which is 49. Is it prime or composite? Prime. Are you sure? No. 7 times 7 is 7 times 7 is 49. So 7 times 7 is 49. So 49 is not prime. It's made up of 7 times 7. And how do I write that in exponential form?
7 squared.
7 squared. Excellent. Number 4. 39. 13 and 3. Very good. This is one of those that I used to always think was prime. One way to check to see is you add 3 plus 9 and you get 12. And you know that 12 is divisible by 3. So therefore 39 is divisible by 3. That was the divisibility rule of 3. And then we realize that it's 3 times 13. And both of those are prime. So therefore I just leave it as 3 times 13. All right, number 5. Is 40 prime or composite? Composite. What is it made up of? 2 times 20, 4 and 8. It doesn't matter what you start with. If you did 2 times 20 versus 4 times 10 or 8 times 5, you would still get the same prime factors. So let's do with 2 and 20. 2 is prime. I always circle what's prime so I know that that one's done. You can. You could do 2 times 10. 2 is prime. And what about 10?
2 times 5.
2 times 5. Excellent. So now you've got yourself 2, 1, 2, 3. So 2 to the power of 3 times 5. And one way to check to make sure that you did it correctly, 2 times 2 times 2 is 8. So I could actually think that this is 8 times 5 gives you 40. So you know that you did it correctly. And if you would have used 4 times 10, you would have still gotten the same thing, because 4 would have broken down to 2 times 2, and 10 would have broken down to 2 times 5. And so in reality you have, again, 3 2s, so 2 to the power of 3 times 5. And again, you can check your work. 2 to the power of 3 is the same thing as 2 times 2, which is 4, times 2, which is 8. And that 8, so this is all equal to 8, times 5 is 40. So if I'm working backwards, how would I write something like this in exponential form? 6 to the power of 3. Very good. So this is all just a quick review of how to write exponential expressions. What about the number 8?
Bob's the 4th.
Yeah, it's 1, 2, 3. There's 4 of them. So it's 5 to the power of 4.
Did I miss 6? Or did we? 9 for 81.
Oh, sorry, I forgot. Thank you. 81.
9.
81 is 9 times 9. Is 9 prime?
No, 3.
No, it's made up of 3 times 3. So this guy is 3 times 3, and that 9 is 3 times 3. So in reality, 3 to the power of 4 is 81. What is number 9 written in exponential form? 9 to the power of 3. Excellent. All right. So that's prime factorization and writing things with exponents. So now let's talk about algebraic expressions. If I know that a number times itself a specific number of times can be written with exponents, then even if the number is an unknown number and we just use a letter to represent it, I should be able to do the same exact thing. For example, the expression negative 8x squared y cubed. This is really made up of negative 8 or negative 1 times 8, because negative 1 times 8 gives you negative 8. X squared means that you have two x's being multiplied together, x times x. And y to the power of 3, which we call y cubed, means you have 3 y's multiplied together. The really important thing to remember is to understand that when you have a negative number, such as negative 8, it's made up of negative 1 times whatever the other number is. But in this case, 8 is not prime. I have to then take negative 8, break it down to negative 1 times 8, And then the 8 itself, break it down to 2 times 4, and the 4 break it down to 2 times 2. So negative 8 written in prime factors is really negative 1 times 2 times 2 times 2. Because 2 to the third is equal to 8. So negative 1 times 2 times 2 times 2 is negative 8.
You get the same answer if you just did it by 8.
As long as you remember that there's negative 1 in front. Because the whole thing is, right? You know that it's negative 8, not just 8. That's why you need to have that negative 1 right here. So when you have a negative number, your factors will always be negative 1 and then whatever the rest of the stuff is. And then the x squared is really x times x, and the y cubed is really y times y times y. These here are not x's, but they're multiplications. Negative 8 is really negative 1 times 2 times 2 times 2. X squared is really x times x. Y cubed is really y times y times y. You try. What is the prime factorization of negative 11m squared? So start with what we call the coefficient. The number in front of a variable expression is called a coefficient. So if I take this, if I wanted to break it down to prime factors, I could take it slow and I could say it's made up of negative 11 times m times m. Do you see that? But negative 11 is really made up of what?
1 times 11.
Negative 1 times 11. So negative 11m squared, if I wanted to break it down to prime factors, it would become negative 1 times 11 times m times m. Remember that when you have a negative coefficient, negative 1 is always a factor of it. You guys try this one. This one should be a little bit easier.
It's not negative. So.
You're right, it's not negative, so I don't have negative 1 as one of the factors.
What is this?
21 times A times B. But what's 21 really made up of? 7 times 3 or 3 times 7. Either order. Let's do it from least to greatest. 21 breaks down to 3 times 7. And what does AB break down to? A times B. That's it. That's the prime factorization. And remember, we're taking it slow, so it's all going to build upon itself. 21 times A times B is really the same thing as 3 times 7 times A times B.
Miss, that's the answer.
That is the prime factorization. You guys try this one. You look at 45j squared k. What do you immediately know you're going to have to break down?
The 45.
The 45. What it's asking me for is prime factors. And prime factors are numbers that cannot be broken down anymore. They can't be divided out anymore. They're only divisible by 1 in itself.
What are we going to use?
So when I look at 45, so 45 is really broken down to 9 times 5. 9 is not prime. 9 breaks down to 3 times 3, and 5 is prime. It's just 5 times 1, so I'll just leave it as 5. J squared breaks down to j times j, and k just breaks down to k. So the prime factors are 3 times 3 times 5 times j times k.
How would you write that though?
You would write it just like that. Those are the prime factors. 3 times 3 times 5 times j times
Would
j
it be
times
like
k.
this equals and whatever?
Yes. Okay, you guys try this one now. So 27 is broken down to 3 times 9. 3 is prime, so I just rewrite them. 9 is 3 times 3. So the 27 is really 3 times 3 times 3. D to the 4 is really d times d times d times d. That's the answer. 3 times 3 times 3 times D times D times D times D. We're expanding it out. That's what we're doing. The reason that we are expanding it out and understanding how to do that is so you can actually start doing operations with them. So, this is called a power. Anytime that you see a base with an exponent, it's called a power. The base can be a value such as 2 or 5 or 3 or a variable. When you have a base and an exponent, it's called a power. When you evaluate a power, going back to the word evaluate, to evaluate, what word do you think of? What everyday word do you think of? When you think of the word evaluate, what other word do you see within that? Evaluate means find the value of. And the word value is telling you it's an actual number. So when you see the words evaluate, what is it asking you to find?
Find the value.
The value. So if I said to you, evaluate 2 to the power of 3, what would you do to find the value of that?
2 times 2 times 2.
2 times 2 times 2, which gives you 8. So if I wanted to evaluate 2 to the third, I would get the value of 8. That leads us to the next part, which is you are going to be asked to evaluate expressions. So when you look at this expression, it looks really, really crazy algebraic. Welcome to Algebra 1. But what does this tell you that you are doing?
Multiplying x by 2.
Not by 2, by itself. Yes. You are multiplying x times itself. And then you're going to do whatever that number gives you. You're multiplying it by whatever y is. Then you're multiplying that by whatever z is. Once you get that number, you're going to take y and multiply it by itself 3 times, and then add those two things together. When you're evaluating, if I had a magic wand that I could just immediately make you know exactly what to do, it would do this. When you go to evaluate, you're going to be plugging things in. When you're putting things in something, I want you to imagine that it's a basket that you're dropping something into. So before you even begin to evaluate, given the fact that they tell you x is equal to -2, y is equal to 3, and z is -1, when you go to evaluate, what you're going to do is you're going to rewrite the problem, but instead of letters, use parentheses, because that's going to tell you what to plug in. So it's going to go x squared times y times z plus y to the third. Then I go back to the original problem and I say, oh, x. Okay, x is -2. So that means I'm going to put -2 wherever there's an x. I'm going to put 3 where there's a y. So that would be here and here. And z is -1. Then you have to use your PEMDAS, your order of operations, so that you don't mess anything up.
It's negative 3 now.
What is the first thing that I'm supposed to do? Okay, inside of the parentheses, there's nothing to be done. What comes after parentheses?
Exponent.
Exponents. So then you're going to go, okay, I have to do -2 to the power of 2. What does that mean you're doing?
2 times 2, or -2 times -2.
-2 times -2, which is
Positive.
+4, times 3 times -1. And what is 4 times 3 times -1?
Well, aren't we supposed to do the parenthesis exponent?
Yeah, plus, what's 3 cubed? You could do that if you wanted to first. What's 3 times 3?
9.
Times another 3.
27.
So this is 27. Now you can go back and do the, what's 4 times 3?
12.
Times -1.
-12.
So that part's -12. plus 27 is
Positive 15.
positive 15, and that's your answer. Okay? So, my advice to you to make sure you never get these wrong, when you go to work on the evaluation of algebraic expressions, you rewrite the problem with parentheses. So x squared becomes parentheses squared times y times parentheses times another parentheses plus parentheses to the third. Then you put stuff in so that you don't lose negatives along the way. And then you do order of operations. Exponents, exponents, and rewrite what doesn't change, and then multiply, and then add. You guys try number 2. The values of x, y, and z are still -2, 3, and -1. So I'm going to start you off by reminding you that the very first thing you do is rewrite the problem with parentheses instead of letters. So that would be 3 times parentheses squared, because that's z squared, times y, which is another parentheses, times z, which is another parentheses, plus parentheses to the third, and then put everything in. My first variable is z. Z happens to be equal to -1. My next variable is y, which is 3. The next one is z again, so that's -1. The last one is x, which is equal to -2. If you take the time to rewrite with parentheses and then put the things in the basket, you're not going to make mistakes as long as you take it slow and you remember your PEMDAS. P for parentheses. There's nothing to really do inside of the parentheses, so I go to E for exponents. Rewrite what doesn't change. So I would rewrite the 3. -1 times -1 is +1, so now that becomes +1. Times 3, rewrite, times -1, rewrite. Plus, what is -2 times -2 times -2? So let's start with the first one. -2 times -2,
4.
+4 times -2, -8. So that part is -8. Now, I can multiply these guys. What's 3 times 1?
3.
Times 3?
9.
Times -1?
-9.
-9 plus -8 is -17. Your negative, remember, you only have a negative and a negative become a positive if you're multiplying or dividing. When you're adding 2 negatives, they become more negative. All right. You guys try this last one.
We do parentheses inside parentheses.
That's correct. So the way I would rewrite it would be like this. I would go, there's a big pop-up parentheses. Inside the pop-up parentheses, there's a little parentheses squared and another little parentheses that's being squared. And then it's minusing 2 times another parentheses. And now the only things I'm substituting are x and y because there's no z's in this expression. X is -2, and that's the first one. And the last one. Y is equal to 3. Order of operations. And you guys you really have to take it slow with this. And remember that these are all the things that, very good. These are all things that we learned at the very beginning of the year that now they're building upon each other. By writing the parentheses first the way that we did, it's going to now make it so that you just have to go slowly. Exponents. What's -2 times -2?
4.
+4. Times, what's 3 squared?
9.
9. And then I have minusing 2 times -2. So it's minus -4, which becomes +4. Or if you wanted to look at it as a different way, you could have said this part here, Negative 2 times negative 2 is positive 4. And then my multiplication comes before addition. 4 times 9 is 36, and 36 plus 4 is 40. So the evaluating is a little bit work because you have to actually plug stuff in. This was basic stuff, evaluating and using order of operations like you guys learned at the very beginning of the year as well as last year. Now that we're dealing with variables and numbers together, it's important that you understand the vocabulary. That which you see here is called a monomial. A monomial, mono means one, think of a monocycle. A monomial is a one-term expression. It's made up of a coefficient, which is the number in front, and then you can have other things being multiplied together. That's just called a monomial. That's it. In this case, this is also called a power. Why is this called a power? Because there's an exponent. That's it. It's a monomial. Power. When you're labeling monomials, when you're calling them by name, monomials are things that are just all being multiplied together. In this case, I'm multiplying 3 times x times y times y. Correct? If I knew what x and y were, I would be able to multiply everything and get one answer. That's why it's called a monomial. Because this together all multiplies to one value if you know what x and y is. When you're multiplying monomials, it's really straightforward. Going to the reason to why we learned about prime factors just a little while ago, here I have two monomials. This is one monomial, 4x squared, and this is another monomial. If you're multiplying this, and this is really important, but it's really easy if you're watching, what you really are doing is you're multiplying 4 times x times x times 5 times x times x times x. It would take a really long and tedious time for us to continuously be writing things like that. And so if you think about what that means in your head, when you're multiplying 4x squared times 5x to the third, it's the same thing as if you were doing 4 times 5 times x times x times x times x times x. So really, you just multiply the 4 and 5 and get 20. And if you have 2 x's here and 3 here, altogether you have 5. Very simple. 4x squared times 5x cubed is 20, because 4 times 5 is 20. And x squared multiplied by x cubed means you have 2 x's, and then you have 3 x's, so really there are 5 x's. You don't know what x is equal to, but you do know that x squared is x times x, and x to the third is x times x times x. So in reality, there's 5 x's together. So when you get stuck, visualize in your head what that means in expanded form, so that then you know, oh, if I have 2 x's and then I have 3 x's, really there's 5 of them being multiplied together. Okay? Similarly with division, when you look at this here, it's a fraction. Forget about the x's for the moment. If you did not have the x's, what fraction is that?
3 over 15.
Which simplifies to?
1 over 5.
Yeah. That part is the easy one to simplify. And then, if you think about the x's, visualize what that means. You have yourself 3 over 15, which is, like you said, 1 over 5, correct? X to the 4 means that there's 4 x's being multiplied.
21.
X to the 2 means there's 2 x's being multiplied. What happens when you have something divided by itself?
It's 1.
It becomes 1, correct? So for every x that you have on top, that there's also an x on the bottom, it divides away. So in reality, the 3x4 over 15x2. 3/15 is 1/5, right? If I have 4 x's on top and I have 2 x's on the bottom, 2 of these x's are going to be divided away by the 2 x's on the bottom, leaving me only 2 x's on top. And that's the simplified form. So the key concept is that when you're multiplying variables, you add their exponents. When you're dividing variables, you subtract them.
Wait, so I don't really, so if it's like division like that, you just, if there's 2 on the bottom, you just take out 2 from the top?
Yeah, that's it. Because anything divided by itself is 1. So if you were to look at this example here, does everybody see how 3/15 becomes 1/5? Does everybody see how the expanded x to the 4 is really x times x times x times x? And the expanded x squared is x times x? And anything divided by itself is equal to 1. So in this case, I could say this x divided by this x is 1. This x divided by this x is 1. And 1 times x times 1 times 1, well, it's just 1. And then there's x squared. And there's no more x's in the denominator because they were both divided away. When you're multiplying, this is the part that now it gets a little bit intense. When you're multiplying numbers together, but you don't know what those numbers are, then in reality what you're going to be doing is you're going to be repeatedly multiplying variables. Okay? So when dividing variables, you subtract their exponents, or you can visualize it. If you look at this example before we finish up, x to the 5 over x to the 2, it means I have 5 x's on top and I have 2 x's on bottom. This x is going to divide away the top one of them, and you're only going to be left with 3 x's on top. That's the reason why it's just x to the power of 3.
Basically 3 over 1.
X to the 3rd over 1. Remember, x is a number that I don't know what it is, so I have to leave it as x. Okay? When you get confused about the rule, when multiplying variables add their exponents, when dividing variables subtract them, if you get confused, write it out. Expand it out the way you learned how to do the prime factors. Okay? So what you guys are going to do is I'm going to record the rest of this so that you can watch it at home. And you are going to do the math space for homework tonight. So if we were going to work on these, you would do 6 times 3, which is 18. B to the 3rd times B to the 4. You can visualize that there's 3 B's here and there's 4 B's here. So altogether there's 7 B's. Or you can remember the rule that when multiplying variables, you add their exponents. So 6 times 3 is 18. B to the 3rd times B to the 4 is B to the 7. Number 2, 11 times 3 is 33. A squared times A6, when multiplying variables, add their exponents. So it's A to the 2 and A to the 6. So there's 2 of these and there's 6 of these. Altogether there's 8. Remember, you keep the variable as a variable because you do not know what it's equal to. Next one, 8 times 9 is 72. C squared is like C times C, and then here's another C, so really there's 3. Number 4, now we're dividing. When dividing variables, subtract their exponents, or visualize it. There are 10 Z's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Z's being multiplied. There are 8 being multiplied at the bottom. Anything divided by itself is equal to 1, so this over this is 1. Z divided by Z is 1, so it's 1 times 1 so far, times 1, times another 1, times another 1. So it's really 1 times 1 times 1 times 1, etc., which is just 1. And then Z times Z is Z squared. So this is really just Z squared over 1, or just Z squared. if you did the rule, you would say when dividing variables, subtract their exponents. So you would get z to the 10 minus 8, which is z to the 2. So either way, you get the same answer. Okay, next question. G to the 12 over g to the 8. You're dividing, so you're going to subtract the exponent. So the variable is g. 12 minus 8 is 4, and that's your answer. All right, number 6. 12 over 18. Remember, this is a fraction. So 12, let's see. We can take 12, and you can either expand it out using prime factors. So 2 times 2, which is 4, times 3, which is 12. And then you have x, and you have 4 y's. And 18 is really 2 times 9, and 9 is 3 times 3. So it's really 2 times 3 times 3. And there's 3 x's and 2 y's. Anything over itself divides away. So this 2 and this 2 divides away. This 3 and this 3 divides away. This x divides away that x. And this y is divided by the bottom, and this one is divided by the bottom. And so what are you left with? 2y squared over 3x squared. That's the reason why we learned how to do prime factors. The other way you could have done it is you could have simplified 12 over 18 and gotten 2/3, and then you could have actually subtracted exponents, like this one's going to take that one away. When in doubt, write it out. So take your time and write it out if you have to. All right. 5 is prime, so I just keep him. M squared is m times m. N is just n. 10 is really 2 times 5. M to the third means there's 3 m's. N to the third means there's 3 n's. This 5 is going to divide away this one. So you get 1, because 5 divided by 5 is 1. M divided by m is 1. M divided by m is 1. This n divided by that n is 1. So your numerator is just 1, because everything else divided away. The denominator is 2. You have 1m, and you have n to the 2. Number 8. Prime factor of 12. 12 is really 2 times 6. 6 is really 2 times 3. So 12 is really 2 times 2 times 3. A to the 4 means you have 4 a's. B to the 6 means you have 6 b's. Denominator 2 happens to be already prime. There are 3 a's and 4 b's. Anything that's on top that's divided by the same on the bottom divides away. 2 divided by 2 is just 1. A divided by A is 1, or it just goes away because you're not going to change the value. So I'm just crossing out or dividing away everything that I have on top with the same on the bottom. Notice that you are going to be left with 2 times 3 in the numerator, which is 6. A b squared over nothing, or just 1, because all of that became 1. So then that means that your final answer is just 6ab squared. All right. Again, you're going to write out the prime factors. 8, 2 times 2 times 2. X to the third is really 3 x's. There's a y. Negative 4, we learned that a negative number always has negative 1 as its number as one of the factors. So negative 4 is really negative 1 times 2 times 2. So I'm going to write negative 1 times 2 times 2. X y squared. Anything over itself divides away. X, y. What's left is 2x squared in the numerator over negative 1, y in the denominator. And negative 2 over negative 1 is really just negative 2. So your answer is just negative 2x squared over y. All right. Last example. Remember, negative numbers are really the same thing as negative 1 times the number. 16 is 4 times 4, which is 2 times 2 times 2 times 2. A to the 4 means you have 4 A's. B to the 2 means you have 2. Negative 12 is the same thing as negative 1 times 4 times 3. So negative 1 times 2 times 2 times 3. A squared, B to the 5th. Anything over itself divides away. A's. There's another A that divides away, B over B and B over B. Now I have to simplify that further. So when I look at this, what do I get on top? Let's see. I get 2 times 2, which is 4. A times A, which is A squared, over, there's a 3 in the denominator, and there's B to the 3. And that's your final answer. So when you're simplifying, write them out. Expand it out with the prime factors so that then you can easily simplify things like just dividing them away or multiply them properly. The last part of this lesson talks a little bit more about what happens when you divide everything away. We know that when we divide everything away, in other words, like 8 divided by 8, it all divides away, you get the value of 1. So, imagine visually what this represents. If I don't know what x is equal to, if I have x to the 4 divided by x to the 4, such as this, if I expand it out, I have 4x is being multiplied on the top and the bottom. Everything over itself divides away, and you're left with the value of 1, but at the same time, you have 0 x's left. This is called the zero exponent rule. Anything to the power of 0 will always give you the value of 1. Do not think it gives you the value of 0. Please make sure you understand what it represents. Again, if you had 4x times x times x times x on top, and it's divided by the same thing, x divided by x is all going to give you 1. So here, this is really 1 times 1 times 1 times 1, because everything over itself is equal to 1, and that gives you 1. But in reality, it gives you no more x's, so their x's are gone. That's the reason why it's x to the 0. So in reality, if the whole thing divided by itself gives you 1, and you get 0 of them, then that's the reason to why anything to the 0 is equal to 1. You will see this in things such as this. For example, 8. I know 8 over 10, you could either simplify it the short way and say, well, 2 goes into 8 4 times, and 2 goes into 10 5 times. So fractionally, it's 4 over 5. And then I can expand this out the long way, m to the 3. And then I could say, well, m over m, m over m, m over m goes away, and all I get is 4/5. The other way you could have looked at it is doing the subtraction rule. You're dividing, so it would be m to the 3 minus 3, which is m to the 0, and m to the 0 is equal to 1. So you would get 4/5 m to the 0, but because m to the 0 is equal to 1, this whole thing is equal to 1, 4/5 times 1 is just 4/5. 8 to the 0 is equal to 1. Anything to the 0 is equal to 1. Because what that is representing is that you had a certain amount of 8s, let's say 4, on the top and on the bottom, and you divided them all away. But when you divide anything by itself, you get the value of 1. Even though there's no more 8s, you still get the value of 1. The next one. it is negative 9x to the 0. So that means that this part is 1, so the whole thing is equal to negative 1. Number 4. This entire thing is being raised to the 0, and so that entire value is just equal to 1. Number 5. Number 5 is telling you negative 12 times x to the 0. So it's really negative 12 times 1, which gives you negative 12. Please make sure you remember anything to the power of 0 is equal to 1. So now what you're going to work on is your F7.2 math space.